Hi, my name is Ubaidullah Mjidi.
And my name is Dalian now.
We are part of Group 6 and we are from A18. The question we will be explaining is question 3b. Find the volume of the solid generated by revolving the region between y equals x squared and y equals 4x minus x squared around the line y equals to 6. As you can see, I have already drawn the graphs and the dotted line, which will be the line we will be revolving around. This line over here represents y equals x squared, and this line over here represents y equals 4x minus x squared. I will erase the lines that we don't need. As you can see, I am left with the region that we need, which is this region over here. To work out where the graphs cut, we do the following. As you can see, I found the x coordinates at where the graphs cut, which is over here and over here. As you can see, the graph is rotated around the y-axis at 6, and the top part would look something like this. It would be hollow in the middle, so we would be using the washer method. Now, for us to find the outer radius, we would say 6 minus x squared. So the outer radius is 6 minus x squared. To find the inner radius, we would say 6 minus 4x minus x squared. I will now hand over to Dalian.
From here we will see that we have been working in terms of x. And so we will be finding the area of A, which is pi, and your outer radius, which was 6 minus x squared, all squared, minus pi, bracket, 6 minus 4x minus x squared, all squared. From there we can simplify. We could take the pi out as a common factor. We do multiplication. We find that it will be 36 minus 12x squared plus x to the 4 bracket minus, we can rewrite this over here as 6 minus 4x plus x squared when we multiply the minus inside, all squared. There we can work out the second factorization, which would be 36 minus 24x plus 6x squared minus 24x plus 16x squared minus 4x to the power 3 plus 6x squared minus 4x to the power of 3 plus x to the power of 4. And from here we can see the x is negative, so it will cancel that x to the power of 4. The 36 will cancel that 36. From here we can add and subtract the other products. We get an answer after adding and subtracting at 8x to the power of 3 minus 40x squared plus 48x. And so we can find the volume of the solid by using the integral, which would mean the volume is equals to the integral, and our bounds was between x being at 0 and it being at 2, and we're working out the integral of the area between the curves. We can just substitute in our answer from there, which would give us pi 8x3 minus 40x squared plus 48x integral. We can take the pi out to multiply after, and we can get the integral of 8x to the power of 3, which would be 8 divided by 4 x to the power of 4 minus 40 divided by 3 x to the power of 3 plus 48 divided by 2 x to the power of 2, and that was between 2 and 0. From there we can substitute in our 2's and our 0's and subtract them from each other, which would be pi is equals to 2 to the power of 4 minus 2 to the power of 0 to the power of 4 minus 40 divided by 3 of 2 to the power of 3 minus 40 divided by 3 of 0 plus 24 times 2 to the power of 2 minus 24 times 0 to the power of 2, where we'll get an answer of that all is 0, so that is 0 and that is 0, so that doesn't account. And then we have pi is 32 minus 320 divided by 3 plus 96, and after all that adding there, we get an answer of 64 divided by 3 pi, and that is the volume of the solid between these two curves, y equals x squared and y equals 4x minus x squared.